NASA Headquarters. This is the administrative and policy center of the entire agency, located in Washington, D.C., where the NASA administrator sets overall strategy and coordinates funding across every other center. Headquarters does not build hardware or launch rockets directly. Instead, it decides which missions get approved, which centers lead them, and how the agency's budget gets divided among all its competing priorities. Kennedy Space Center. This is the launch site most people picture when they think of NASA. Located on Florida's coast and responsible for final vehicle assembly, launch operations, and every countdown that has ever sent American astronauts into orbit. Every crewed mission since the Apollo program, including the Space Shuttle era and today's Artemis program, has lifted off from this exact location. The center also manages the massive Vehicle Assembly Building, one of the largest structures by volume ever constructed, where rockets are stacked vertically before making the slow crawl out to the launch pad. Why does geography matter so much here? Because launching from a coastline near the equator gives rockets an extra push from the Earth's rotation, and Florida's location made it the obvious choice from the earliest days of the space race. Johnson Space Center. This is the home of Mission Control, located in Houston, Texas, and responsible for human spaceflight training, astronaut selection, and real-time operational command once a crewed mission leaves the ground. Every famous phrase in spaceflight history involving mission control, including the tense communications during Apollo 13's crisis, originated from consoles inside this exact center. This is also where every American astronaut candidate trains before ever stepping foot on a launch pad, spending years mastering spacewalk procedures, robotics, and emergency protocols long before their first flight assignment. Marshall Space Flight Center. This is the propulsion engineering hub of NASA, located in Huntsville, Alabama, and responsible for designing and testing the rocket engines that actually get spacecraft off the ground. Rocket engineer Wernher von Braun served as this center's first director after leading the development of the Saturn V rocket that carried astronauts to the moon. Marshall continues that legacy today, leading development of the powerful Space Launch System rocket used in NASA's current Artemis missions. Goddard Space Flight Center. This is NASA's largest center focused on Earth and space science, located in Maryland, just outside Washington, and responsible for building and operating many of the agency's most important satellites and space telescopes. The Hubble Space Telescope and the James Webb Space Telescope are both operated out of this single center, making it the nerve center for some of the most detailed images humanity has ever captured of the universe. Goddard also manages a large fleet of Earth-observing satellites that track hurricanes, wildfires, and climate patterns in near real time. Jet Propulsion Laboratory. This is NASA's center dedicated to robotic exploration of the solar system, located in Pasadena, California, and uniquely managed by the California Institute of Technology, rather than directly by federal employees. Every Mars rover NASA has ever landed, from Curiosity to Perseverance, was designed, built, and is remotely operated from this single facility. Engineers at this center also plot the intricate gravitational paths that let spacecraft slingshot past other planets, saving enormous amounts of fuel on missions that can last well over a decade. That management structure makes this the only major NASA center not staffed primarily by direct federal civil servants. Ames Research Center. This is a center focused on aeronautics research, astrobiology, and advanced computing, located in California's Silicon Valley, giving it close ties to the technology industry surrounding it. Ames also manages some of NASA's most powerful supercomputers, which are used to simulate everything from spacecraft re-entry heat to the search for habitable planets beyond our solar system. Langley Research Center. This is NASA's oldest field center, located in Virginia, and originally established decades before NASA itself even existed, when it operated under the agency's predecessor organization. Mathematician Katherine Johnson worked at this exact center, performing the orbital calculations that helped send the first American astronauts safely into space, and later confirmed by early computers as accurate. Langley today continues its original focus on aeronautics, testing how aircraft and spacecraft actually behave in flight. Glenn Research Center. This is a center focused on propulsion systems and aeronautics research located in Cleveland, Ohio, and responsible for developing power systems used in deep space missions far from the sun's reach. Glenn's engineers specialize in problems unique to extreme environments, including how to generate electricity for spacecraft traveling too far from the sun for solar panels to work efficiently. The center's massive vacuum chambers also allow engineers to simulate the airless, freezing conditions of deep space right here on the ground. Stennis Space Center. This is NASA's primary rocket engine testing facility located in Mississippi, where every major liquid-fueled engine used in American human spaceflight has been static fire tested before ever leaving the ground. This center exists specifically because testing a rocket engine at full power requires enormous open space and strict safety buffers that few other locations could safely provide. Stennis surrounds its test stands with thousands of acres of undeveloped buffer land, absorbing the sound and shock waves that a full engine firing produces. Armstrong Flight Research Center. This is NASA's center dedicated to experimental aircraft testing, located in California's Mojave Desert, where test pilots push new aircraft designs to their absolute limits under real flight conditions. This center's remote desert location and famous dry lake bed runway make it one of the few places in the country where experimental and often unstable prototype aircraft can be tested safely. Now here is the detail almost nobody expects. These 10 centers do not simply divide the work evenly. A single mission often depends on multiple centers working together in sequence, with one designing the spacecraft, another building the engine, another training the crew, and another operating mission control once it launches. The Artemis program alone depends on Marshall's rocket, Kennedy's launch pad, Johnson's mission control, and Goddard's communication satellites relaying data back to Earth throughout the entire mission. Wallops Flight Facility. This is a launch facility focused on suborbital rockets, atmospheric science, and technology testing located on Virginia's eastern shore along the Atlantic coast. Unlike NASA's larger launch centers, Wallops regularly launches smaller research rockets that carry scientific experiments high into the atmosphere before returning to Earth. The facility also serves as a testing ground for new space technologies, allowing engineers to validate hardware in real flight conditions before it is used on larger and more expensive missions. There is another layer worth understanding. Not every center reports to headquarters in exactly the same way. The Jet Propulsion Laboratory's unique relationship with Caltech means it operates with more institutional independence than any other center in the agency, even though it still receives its funding and mission assignments directly from NASA. That structural difference occasionally creates friction over how projects get managed, but it has also allowed JPL to build a distinct engineering culture focused specifically on robotic deep space exploration, one that looks noticeably different from the more traditional government culture found at centers like Marshall or Johnson. What does this mean for you? It means the next time you see a NASA headline, you can immediately picture where that story actually originated. A rover landing on Mars points to the Jet Propulsion Laboratory. A rocket static fire test points to Stennis. Astronauts training for a mission points to Johnson. A new satellite image of a hurricane points to Goddard. NASA is not a single organization doing everything from one location. It is 10 highly specialized centers, each mastering one piece of an extraordinarily complicated puzzle, coordinated by a headquarters that never touches the hardware itself. NASA is not one building in Florida with rockets launching out of it. Now you can name every center that actually makes spaceflight possible, and you understand exactly what role each one plays before a single rocket ever leaves the ground.